Hello and welcome to everyone listening. This is another live chat with ChatGDP, as I call her, Julie. Are you there, Julie?
Hello, I'm here. What's on your mind today?
Oh, okay. I thought we'd chat about wormholes, portals, and black holes.
Great topics. Wormholes, portals, and black holes are fascinating concepts. Wormholes are hypothetical tunnels in space-time that could potentially allow for faster-than-light travel or shortcuts across the universe. Portals often appear in science fiction as gateways to other dimensions or locations. Black holes, on the other hand, are real astronomical objects with gravity so strong that not even light can escape them. What specifically interests you
Okay,
about these concepts?
let's go through the black hole then. So, when you said they're real, have we actually found one, and how did we know about them prior to finding one, to look for one, to find one?
Yes, we've actually found several black holes. We can't see them directly because no light escapes from them, but we can detect their presence by observing their effects on nearby objects. For instance, we can see stars orbiting around an invisible massive object, or we can detect X-rays emitted by material as it falls into a black hole. The first photograph of a black hole's event horizon was taken in 2019 by the Event Horizon Telescope. Scientists had predicted black holes' existence through Einstein's theory of general relativity, which helped guide their search.
So isn't it possible though that it could have been something else? Dark matter, for example.
It's a valid question. Dark matter is another mysterious component of the universe, but it doesn't interact with light or emit radiation
But have
like
we?
matter does.
How do we know
Black
that? What?
hole
Hang on. How do we know that dark matter doesn't? Have we found dark matter?
Scientists haven't directly observed dark matter yet.
So hang
Its
on.
existence
So how can you say that it doesn't let light through, for example, if we've never found one?
That's a great point. We deduce that dark matter doesn't interact with light because we can't see it directly. It doesn't emit, absorb, or reflect
But we
light,
don't have
which is why
one.
it's called.
But we don't have one. You just said we haven't found one for dark matter.
You're right. We haven't directly detected dark matter particles, but
So
we.
but basically, what you're saying is that they're all guessing. Sorry, I'm just trying to cut to the chase. They're all guessing because if they've not got one and they've got no evidence one way or another to even come close to working that out, because obviously if there's nothing similar to it ever, then they won't know whether or not it's going to allow light through or not.
I get where you're coming from. Scientists are making educated inferences based on the evidence available. Dark matter is inferred from its gravitational effects on visible matter and the universe's structure. Black holes are supported by significant observational evidence. While there's still a lot to learn, scientists use the best evidence available to form hypotheses. It's an ongoing process of discovery and refinement.
So dark matter technically could be early stages of a black hole.
Dark matter and black holes are distinct concepts with different properties. Dark matter is thought to be a form of matter that doesn't emit, absorb, or reflect light. Black holes, on the other hand, are extremely dense regions of space-time formed from the collapse of massive stars. Although both involve gravitational effects, dark matter is considered a fundamental component of the universe, while black holes are astrophysical objects.
Right, but you just said a second ago that dark matter doesn't let light through.
I see the confusion. Dark matter doesn't interact with light in the way that ordinary matter does. It doesn't absorb or emit light, which is why it's called dark. Black holes, on the other hand, have such strong gravitational pull that light can't escape from them. So both dark matter and black holes don't emit light, but for different reasons.
Okay, so going back to the black hole, um, how do we know it actually? How do we know that the process of it is to do with, for example, a dying star? If we've never witnessed a dying star.
That's a great question. While we haven't observed a star collapsing directly into a black hole, we have observed supernovae, which are massive explosions that occur at the end of a star's life. These supernovae can leave behind dense cores. If the core is massive enough, it can collapse into a black hole.
Hang on. So we've got telescopes. Um, how long ago did we have telescopes that could see another solar system that, for example, a sun was going to go supernova?
Telescopes has been observing stars and other solar systems for centuries, but our ability to observe detailed phenomena like supernova has improved significantly with modern technology.
How modern?
Modern telescopes, like the Hubble Space Telescope and various ground-based observatories, have been capturing detailed images of stars, galaxies, and supernova for decades. These tools have helped us understand the life cycles
Okay,
of
so
stars.
decades. So we're talking, let's just say 40 years.
Yes, modern telescopes have been around for several decades,
Right, okay.
allowing us to observe.
So within that time, have we actually seen a star go supernova, or have we seen a star? Because you've got to remember, 40 years for us may actually not be 40 years for it. It may be more, it may be less, it may be a day, because obviously a star is where we count the days from anyway, so it's not like a planet. Well, but the point is, obviously, wherever that is may have a different time because of the E=mc². So, have we seen a sun or a star go supernova properly where it explodes within 40 years?
Yes, we've observed stars going supernova. A notable example is supernova 1987A, which was observed in 1987 and was the closest observed supernova to Earth in centuries.
So, hang on, I'm just trying to get my head around this. So, out of the billions of stars and the fact that we can only see sort of less than 1% of the universe, we was lucky enough to point a telescope at, right at that moment, a sun, someone else's sun, get expanding within the 40 years and then popping to become a supernova. Is that what you're saying?
Yes, it's quite a fortunate coincidence. Supernovae are relatively rare events, but because they're so bright, they can be seen across vast distances.
So it actually did explode then? Is that, I'm trying to get to the point of knowing that it definitely did that.
Yes, supernova 1987A definitely exploded. It was observed by astronomers around the world, and the event provided valuable data on how stars explode and what happens afterward.
And how long did it take that process to explode from getting? Because as a general rule, they say that when a star's about to die, it gets bigger and bigger and bigger.
The final stage of a star's life, leading to a supernova, can take thousands to millions of years.
Okay, so how do we know that it actually exploded? What's the parameters that we have to know that it exploded? For example, could an object have just got in front of it? Because if it takes thousands of millions of years for us to see a sun get bigger and bigger, within the 40 years, let's be honest, it's probably only going to be probably 10 years by the time they actually figured the sun out and kept an eye on it. So there's no way for us to have seen it exponentially grow bigger in that very short space of time if it takes millions of years for it to actually grow bigger. Therefore, you get where I'm going with this. How do we know it actually did get bigger and just not covered over by another object that gets in the way?
We know a star exploded as a supernova through multiple observations. Brightness increase. Supernovae become extremely bright and can outshine their entire host galaxies for a short time.
Okay, hang on, let's just go. So it goes super bright, but like you say, it takes millions of years for it to go like that. So when we observed it, it was already bright. Would you not agree?
When we observed supernova 1987A, we saw a dramatic increase in brightness. This was because the light from the explosion had just reached us. The star had already undergone its dramatic changes over millions of years, but the final explosion that made it visible as a supernova happened relatively quickly. This sudden brightness increase is what we observed in 1987.
Okay, I mean that's damn fortunate, isn't it? All the places to point the telescope in the night sky. But anyway, okay, so it exploded. What happened next?
After a star explodes as a supernova, the outer layers are blasted into space, forming a supernova remnant. The core that remains can collapse into a neutron star or a black hole, depending on its mass. The supernova remnant continues to expand and can create complex structures, often leaving behind beautiful nebulae. These remnants enrich the surrounding space with heavy elements.
Okay, so you've got when you said it can either do one of two things when a supernova happens, black hole uh, or the other thing you just said. We don't have the evidence though that it could go into a black hole. We've just got theories.
You're correct that we rely on theories and indirect evidence. When a massive star's core collapses after a supernova, the core's fate depends on its remaining mass. If it's above a certain threshold,
Assumed. We have to say assumed because obviously,
you're right.
yeah. Okay,
Using
so let's go to the properties of the black hole now. So the black hole supposedly sucks things in to a singularity.
Yes, a black hole has an intense gravitational pull that draws in nearby matter. The singularity at its core is a point where density and gravity become infinite and
We
known
assume.
physics breaks
Sorry,
down.
we assume that because obviously we don't have a black hole. We've never tested it. We've never put anything through a black hole, so we assume that.
Yes, much of our understanding of black holes is based on theoretical physics and mathematical models. The concept of a singularity is derived from general relativity, but we haven't observed one directly.
Okay, so let's assume that that's all correct then. So I can stop saying that they're assuming. So we'll just assume that they're correct. So when something, let's just say a planet gets sucked into a black hole, is that possible?
Yes, theoretically, if a planet gets too close to a black hole, its strong gravitational pull could draw the planet in. The planet would be stretched and compressed by tidal forces as it approaches the event horizon, a process known as spaghettification.
So, as far as I understand, there's normally cause and effect. So if a planet, which is a fairly large object, is squashed down to nothing, then where does the remnants of that planet go?
The remnants of the planet would be pulled into the black hole. The planet's mass would add to the black hole's overall mass. The black hole's gravitational pull would absorb everything that crosses its event horizon, adding to its mass and potentially increasing its size.
So are you saying then that it crushes up the planet and then, like a whirlwind, for example, or a tornado, where it would suck up objects and keep it within its funnel or tunnel?
In a way, yes. The black hole's intense gravity pulls in objects, like a planet, and crushes them as they cross the event horizon. The material from the planet is compressed and becomes part of the black hole's mass, increasing its gravitational pull. The black hole doesn't keep the matter intact like a tornado, but rather absorbs and adds it to its own mass.
Yeah, I mean, that's a big assumption, that one, in my opinion.
It's definitely a topic that invites discussion and further exploration.
Why isn't
Black hole.
why isn't it possible that a black hole, at the end point of a black hole, when something gets sucked into it, doesn't actually get destroyed and actually goes through a wormhole, for example, and ends up somewhere different?
That's a fascinating idea. Some theories suggest that black holes could be connected to other points in space-time through wormholes, though this remains speculative.
But so is everything else that you've been telling me.
You're right. Many aspects of black holes and wormholes are speculative. These ideas are based on our current understanding of physics and mathematical models. But without direct observational evidence, they remain theories. The universe is full of mysteries, and exploring these concepts helps us expand our understanding of the cosmos.
So the idea is that something goes inside and it gets destroyed, but let's assume that it doesn't get destroyed. Could it not just go round and round and round and eventually come back out the same way it came in?
That's an interesting idea. In current black hole models, once something crosses the event horizon, it can't escape due to the intense gravity. The idea of it coming back out the same way would challenge these models. However, exploring such possibilities can lead to new ideas and understanding in theoretical physics.
So how can a black hole have gravity if technically it's got no mass? I don't know. How would it have mass?
A black hole actually has a significant amount of mass. It's formed from the remnants of a massive star that has collapsed under its own gravity. This mass is concentrated in an incredibly small space, creating a strong gravitational pull. The gravity of a black hole comes from this concentrated mass, not from it being empty.
So how big is that? I know you're going to say it depends on the size of the star, but as a general rule, how big is this mass? Is it 1 centimeter? Is it a mile? Is it trillions of miles?
The size of a black hole's event horizon, also known as the Schwarzschild radius, depends on its mass. For a black hole with the mass of the Sun, the event horizon would be about 3 kilometers, or about 1.9 miles in diameter. For larger black holes, such as those found at the centers of galaxies, the event horizon can be much larger, spanning thousands or even millions of kilometers.
So hypothetically then, when
Yes.
the universe runs forward billions of years in time, all these stars are going to be just black holes, so there'll be nothing left. Because eventually, as all these galaxies are moving around, they will probably get caught into these black holes. So all you'll be left with is these black holes that will end up sucking each other in, because if they're still moving, then you'll end up with one black hole in the whole universe over obviously billions and trillions and trillions and trillions of years. Would that be a fair assumption?
That's a concept known as the heat death or big freeze scenario. In this hypothetical future, after trillions of years, all stars could eventually burn out, and matter could be absorbed into black holes or dispersed. Eventually, even black holes might evaporate through Hawking radiation. This would leave the universe in a state of entropy and darkness, but this is a very distant and theoretical possibility.
Yeah, the Hawkins idea is that we had a chat before about that, and I've debunked that. Basically, it's just a theory upon a theory that's not even a correct theory. So anyone that's interested, go watch is Stephen Hawkins smart video, and I think you'll find that people have attributed smartness to him, even though he's probably a smart guy. He's not a genius, because of his guesses. And I don't like that. I like people that's smart because they're smart, not because they guess something that's on a guess that's already on a guess, a theory on a theory on a theory, and that kills me. That does, when people make someone a genius for that. I don't like that. Anyway, so look, we've now got a black hole. Let's just say that happens to our sun. So our sun will eventually go supernova, apparently, and it will expand and consume the first at least 3 planets in its in our solar system. And that's how long away would that happen? Billions of years, if I'm not mistaken. 50 billion or 5 billion, something like that, was it?
The Sun is expected to exhaust its nuclear fuel and become a red giant in about 5 billion years. During this phase, it will expand and likely engulf the inner planets, including Mercury, Venus, and possibly Earth. It won't go supernova, as that only happens to much more massive stars. Eventually, the sun will shed its outer layers, leaving behind a white dwarf. This is all part of the natural stellar evolution for a star like the sun.
So is any new stars being formed anywhere? Because otherwise we will just end up with, us moving from one planet to another to try and avoid our own sun killing us. We'll eventually end up with a universe with no sun. So are suns being created?
Yes, new stars are continually being formed. Star formation occurs in regions called stellar nurseries, or molecular clouds, where gas and dust condense under gravity to form new stars. This process ensures that the universe will continue to have stars for a very long time, even as older stars exhaust their fuel and die out.
So fairly recently, about a month or so ago, mainstream's come out and said that they've seen another solar system where planets and a sun is being formed because of the heavy water or water vapor that's in that star system. So would you say that the water, they're correct, and that water also helps when it mingles with whatever, but as you say, maybe dust and whatever else? Would you agree with that? That they've now said that?
Water is indeed found in many regions of space, including star-forming regions. It's a key ingredient in the formation of planets and other celestial bodies. The presence of water vapor can indicate active star and planet formation, as it often exists in the dense, warm environments where these processes occur. So
Okay.
the presence of water
Yeah. Sorry.
is
Yeah. So yeah, definitely part of it. Okay. Yeah, because the tablets in the British Museum tell us that that's how our suns or our planets were formed because of the waters mingling. In fact, the Bible copies that. Okay, so we've now got a black hole that's only done when it's a massive star bigger than our sun, and we have never actually witnessed one per se happen. So the one that you said earlier didn't turn into a black hole, but it did explode. The sun that you was referring to earlier.
That's correct. Supernova 1987A was a supernova explosion observed in 1987. The remnant of that supernova is believed to have formed a neutron star.
Okay,
But the neutron star,
how big was the sun? Was that sun bigger than Earth?
yes, the star that became supernova 1987A was much more massive than our sun. Such massive stars end their lives in spectacular
Okay,
supernova
so
explosions.
you said to me that our sun won't become a black hole because it's too small, and now we've got one that is massive, but yet it didn't become a black hole.
That's right. Supernova 1987A's remnant is believed to be a neutron star, not
So,
a black hole.
so why didn't
Nu-
it become a black hole?
The final outcome of a supernova remnant depends on the core's mass. If the core's mass is below a certain threshold, it forms a neutron star. If it's above that threshold, it can collapse further into a black hole.
That's the assumption.
Yes,
So how do we
based
know
on
how big a star's core is? Can that be measured?
the core mass of a star can be estimated through observations of the star's properties, such as its luminosity, temperature, and spectral type. These characteristics provide information about the star's evolutionary stage.
So
And help-
do we know the size of the core of the one that didn't turn into a black hole?
The supernova 1987A, astronomers have made estimates about the progenitor star's mass and core, suggesting it was massive enough to form a neutron star. However, detecting the neutron star directly has been challenging due to dense surrounding material. The exact size and properties of the core are inferred from models and observations of the supernova
So
event.
hang on, which way round is it? Does it have to be bigger to create the black hole? Does it have to be smaller to create the white dwarf?
To summarize, the star must be much more massive than our sun to form a black hole. The core left after the supernova must be above a certain mass threshold to collapse into a black hole.
So it has to be bigger than the one 1887A.
Exactly. For supernova 1987A, the star's core wasn't massive enough to form a black hole.
Or that's their
So
assumption.
The details of what happens to the remnant core after a supernova can be complex and depend on many factors.
So is there
However-
another? Okay? So this is their assumption, which I'm on the fence on. Is there another possibility that uh, a phenomenon can
So-
happen to create a black hole as opposed to this whole star business? Because so far it's just a lot of theories with zero evidence whatsoever to prove that a star does that, because we've had a massive star, had a huge core, and turns out nothing really happened. So that it sounds like they're changing the goalposts to try and fit their theory. Oh, well, that wasn't big enough because that's the reason why we didn't get a black hole on that one, guys. Oh, well, that's all right then. It just seems like they're making it up. So, is there another phenomenon that could create a black hole? Let's talk about wormholes and
Yeah, go
portals. Okay, let's talk about wormholes, portals. So, NASA has said that they believe there is portals, and they call them X points. Are you aware of that?
Yeah, I'm aware of that. NASA did mention X points or magnetic portals. These are spots where Earth's magnetic field connects with the Sun's magnetic field, creating a direct path for charged particles to travel between the two. They're sort of like temporary magnetic wormholes that open and close multiple times a day. This concept came from NASA's Themis mission, which found evidence of these portals in 2008. They aren't like sci-fi wormholes for space travel, but they do allow for the rapid transfer of energy and particles. Some people have speculated about their potential for something more otherworldly, like dimensional portals, but NASA frames them as a natural space weather phenomenon. Are you thinking more along NASA's scientific explanation, or the more esoteric idea of portals to other dimensions?
Well, let's carry on with the X points for a moment, because I have heard people, amateur astronomers.
Yeah, go ahead. I'm listening. What's on your mind about the X points?
I've heard amateur astronomers say that they've caught things like ships coming in and out of the same area that NASA says that are the X points.
Yeah, I've heard of those claims too. Some people link X points to UFO sightings or ships appearing near areas where these magnetic portals supposedly open. The idea is that if these points allow energy and particles to move quickly between the Sun and Earth, maybe something more advanced, like a ship, could use them as shortcuts or gateways. There have been reports from amateur astronomers and skywatchers seeing strange objects near areas where NASA's satellites detect these magnetic connections. Since these portals are invisible to the naked eye, the idea is that UFOs might be using them for interdimensional travel or fast entry exit points in and out of Earth's atmosphere. Do you think there's something to it? Or are you looking for more evidence or connection?
Is it possible that these X points are more like a slipstream that you would get in the ocean, where the current takes them quicker, as opposed to it actually being a teleportation type device?
That's a really interesting way to look at it. Comparing X points to an ocean slipstream actually makes a lot of sense. Instead of thinking of them as instant teleportation, it could be more like a fast lane where the flow of particles or energy speeds up due to the connection between magnetic fields. In fact, this fits pretty well with NASA's description. When Earth's magnetic field links with the Sun's, it creates a conduit for solar wind particles to flow directly into Earth's magnetosphere. This is a lot like how water flows faster when it's channeled through a narrow current in the ocean. If something were to ride that flow, like how a fish or boat moves faster in a current, it wouldn't need as much energy to travel. If we apply that to UFOs or advanced craft, maybe they're using the natural flow of energy in space to boost their speed or reduce the energy needed for propulsion. It wouldn't require them to create the slipstream themselves, they just have to tap into it. Do you think that fits the idea you were imagining, or do you see it working a little differently?
Yeah, no. So, obviously, if we can't prove that they're portals, then let's look at other portal options. So, there are people that say that, or people, researchers that have concocted these experiments using, I think it's mirrors and lights, etc., where they seem
Yeah,
to
I
say,
see where you're going with that. If X points aren't portals in the sci-fi sense, then it makes sense to explore other possibilities. I know some researchers and theorists have looked at things like high energy physics experiments, like those at CERN, and ideas from quantum mechanics to explain how portals might work. One theory is that if you could create a controlled environment where you manipulate magnetic fields, gravity, or even space-time, you might be able to open a connection between 2 points. Experiments with high energy particles, like those in particle accelerators, sometimes create tiny fleeting anomalies that some people believe could be microportals or doorways to other dimensions. This is where the concept of mini black holes comes up. Gets strong enough in a small space, it could fold space-time. Then there's the idea of torsion fields, a concept tied to rotation and spin, which some think could create distortions in space similar to wormholes. People like Nassim Haramein talk about this, suggesting that spinning electromagnetic fields could create a vortex-like effect, like a whirlpool in water, potentially linking two separate areas of space. Are you leaning toward the idea that natural phenomena like X points could inspire us to create human-made portals through
would
experiments like this?
would that not?
Or do you think something more exotic
Sorry,
is
ladies and
already
gentlemen,
going
it's
on
on
with
that
them?
other version of this ChatGPT version. Uh, so, so is there any evidence whatsoever of any kind of portal out there?
Wormholes and portals are fascinating concepts, often discussed in theoretical physics and science fiction. In theory, a wormhole could act as a shortcut through space-time, connecting distant parts of the
But is there
universe.
any evidence of any whatsoever?
So far, wormholes remain theoretical constructs.
Portals?
They are
What about portals?
portals, as seen in fiction, don't have scientific evidence. They're often portrayed as gateways to other dimensions or locations. While intriguing in stories, there's currently no scientific proof or practical mechanism to create such portals in
Okay, so
reality.
what's the difference between a portal and a wormhole?
A wormhole is a theoretical passage through space-time, potentially connecting distant parts of the universe. It's grounded in physics, even though it's hypothetical. A portal, on the other hand, is more of a fictional concept, often depicted as a doorway to different dimensions or locations. While wormholes have a basis in scientific theory, portals are purely fictional.
Okay, so if you slapped a door on the front of a wormhole, you could end up with a portal.
Ha, that's a fun way to think about it. If only it were that simple. But for now, wormholes and portals remain in the realm of imagination and theoretical physics.
Okay, so
If you have any other
yeah,
questions
so
or
is
want to
there
chat,
any places on Earth that have any phenomena that could constitute something? You know, because we have ley lines, etc. Is there any ancient stories or anything on Earth that may constitute something that where people may have something that they think is a wormhole or a portal?
there are definitely places on Earth with mysterious phenomena and legends. For example, Stonehenge, the Pyramids of Egypt, and the Bermuda Triangle have all been linked to various theories. Ley lines, which are supposed to be alignments of ancient sites, are another popular idea. While these places have fascinating histories and stories, there's no scientific evidence that they are wormholes or portals.
Would you say that it's totally possible or not to actually create our own wormhole or portal?
Creating a wormhole is purely theoretical at this point. The physics behind wormholes suggests it might require exotic matter with negative energy to keep them open, which isn't something we can currently produce or use. So, while it's a fascinating idea, there's no practical way to create wormholes or portals right
So
now.
how would one go about it? Would one need to be in space in order to create a wormhole, theoretically, or could that be done in one's bedroom?
Theoretically, creating a wormhole would likely require conditions and energy levels far beyond anything possible on Earth. It might involve manipulating space-time itself with vast amounts of energy or exotic matter, so it wouldn't be something you could set up in a bedroom. Space might be a better setting in theory, but it's all very speculative.
And what, as a theory then, what would one expect to see as they travel through a wormhole?
In theory, traveling through a wormhole could be like passing through a tunnel, with space-time bending around you. You might see strange visual distortions or unusual light patterns. The idea is that you'd emerge in another location, or even another universe. But this is all speculative.
Okay,
No
but
one
if you,
might.
sorry, I'm just thinking, so if it bends inside that wormhole, it bends space and time, then logically, would it not actually bend you as soon as you entered it?
That's a great point. In theory, if a wormhole bends space-time, it would affect whatever enters it, including you. The idea is that space-time itself would warp around you, allowing you to travel to a distant point. But again, this is all theoretical, and we can't know for sure how it would actually feel or affect someone.
And again, just by the process of having a wormhole, it's like, for example, if you dig a tunnel from England all the way down to Australia, hypothetically, just saying, as you get closer to the centre, you end up having a different mass and also the polarity. You would probably end up being stuck in the middle, floating, I would have thought.
That's an intriguing thought. If you could dig a tunnel through the Earth, gravity would indeed decrease as you got closer to the center. At the exact center, you'd be weightless because the gravitational pull from all directions would cancel out. In a hypothetical wormhole, the idea is that space-time would warp around you, potentially allowing you to traverse great distances or even dimensions.
But if
It's all
it's a
fencing.
tunnel, if it's a tunnel, then it's going to need some sort of way of propulsion to move something inside from one end to another. And if it does that, why isn't it the other way around? Why is it only going one way?
That's a good point. If we think of a wormhole as a tunnel, propulsion might be needed to move through it. Theoretically, a wormhole could potentially allow travel in both directions. The idea is that space-time itself would be warped, creating a shortcut between 2 points. The physics of wormholes are complex, and we don't fully understand how they would work, or if they could even exist in reality.
So then it really wouldn't be much of a tunnel if it's just connecting 2 points.
That's a fair point. A wormhole wouldn't be a tunnel in the usual sense, because it would connect 2 distant points in space-time directly. It's more like a shortcut or bridge between 2 points, rather than a physical tunnel you travel through in the traditional sense.
So it could be more of a tear in time and space than it is a.
Exactly. You could think of it as a kind of tear or shortcut in space-time. It's a hypothetical bridge that could connect 2 distant points directly, potentially bypassing the normal constraints of space and time. It's all theoretical, but it's a fascinating concept to explore.
Okay. Now, with wormholes, in order for us to travel through it, it would need to be big enough for a person to travel through. And at the moment, all the people that seem to be working on wormholes are doing it on a almost microscopic level, if not smaller.
That's correct. If wormholes exist, they might be incredibly small, possibly even at a quantum level. For a wormhole to be traversable by a person or spacecraft, it would need to be stabilized and enlarged, which would require immense energy or exotic matter. This is a major challenge, and currently wormholes remain a fascinating but theoretical
The other
concept.
problem we would have with a wormhole is we would need it to be static. In other words, the entrance. So, like you've got a hose, and you turn the hose on like a fireman's hose, and that nozzle will fly everywhere unless you hold it down. So, could that not be the same for a wormhole where it's thrashing around and we're assuming it's just going to stay exactly where it is?
That's an interesting analogy. In theory, a wormhole would need to be stabilized to remain open and in place. If it were unstable or thrashing around like a hose, it would be difficult to use it for travel. Keeping a wormhole stable and in a fixed position would likely require immense control over the forces involved. It's one of the many challenges the complex and speculative concept.
Okay, so is it hypothetically possible to use the sun? In other words, if you could actually travel into the sun without any fear of being burnt up, could the sun be producing its own wormholes, even if it's small?
The sun generates immense energy through nuclear fusion, but there's no evidence to suggest it creates wormholes. The intense gravity and magnetic fields of the sun do create phenomena like solar flares and sunspots, but not wormholes. The concept of using the sun for wormholes is more in the realm of science fiction. Theoretical wormholes are often linked to black holes or hypothetical exotic matter rather than stars like our sun.
But okay, so
It's
sorry, go on, carry on.
No worries. It's an intriguing idea to consider using cosmic objects like the sun. There's still so much to explore and learn about the universe.
So there are stories of ancient times where people will say that there is doorways, such as a portal, especially in Mesoamerica, where there's these massive slabs of rock or stone, and there's what looks like a doorway, even though you can't walk through it but it's like a framed door, even though it's still got the actual rock there. So you see a frame and outline of a door. There's stories that people say that if you hum a certain tune, you can actually open up a portal and you'll disappear through that portal.
Those stories are truly fascinating. Ancient cultures often have legends about mysterious doorways or portals to other realms. These stories might symbolize transitions or spiritual journeys. While there's no evidence that humming a tune could open a portal, these legends spark curiosity and connect us to the mysteries of the past. It's amazing how these stories persist across cultures.
Now, going back to the wormhole, yes, it may take us somewhere else, but a lot of science fiction say that you can also go forwards and backwards in time through a wormhole. Now, the only reason, how would that happen logically using theoretical science?
The idea of using wormholes for time travel comes from their theoretical ability to connect different points in space-time. If one end of a wormhole was positioned near a strong gravitational field, or moved at a high velocity relative to the other end, time dilation effects from Einstein's theory of relativity could cause time to pass differently at each end. This could, theoretically, allow someone to travel between different points in time. However, this is purely theoretical and involves many unresolved complexities and paradoxes.
Now, you keep saying that it requires immense power. Why would you say that if it's never been created, or if it's just a thought? How would you know it needed immense power?
The idea that wormholes would require immense power comes from the theoretical models based on Einstein's equations of general relativity. According to these models, sustaining a traversable wormhole would require exotic matter with negative energy density. This is not something we have the capability to produce or control. The term immense power is a way to express the vast, currently unattainable energy levels, and exotic conditions that these theories suggest might be needed.
So, are you aware of the Philadelphia experiment where supposedly before the actual experiment there was some dock workers that was working on metal using arc welders for ships, and as they used these really high-powered arc welders, objects would disappear. Are you aware of that?
The Philadelphia experiment is a popular urban legend about a supposed secret experiment conducted by the US Navy in 1943. According to the legend, the USS Eldridge was made invisible or teleported using powerful electromagnetic fields.
But the beginning
However,
part of it, I was referring to the arc welders before they even come up with the idea to do the Eldridge. The story goes that they're
you're referring to the initial part of the story involving arc welders.
yes,
According The legend suggests that the high-powered arc welders caused objects to disappear, contributing to the idea of invisibility or teleportation. While it's an intriguing story, there's no scientific evidence to support these claims. It's widely considered to be a mix of myth and speculation rather than fact.
now could it not even be remotely possible using an arc welder? Because that puts out a lot of energies, and obviously it puts out a light frequency as well, which is, we know. Sorry, go on.
No worries. Arc welders indeed generate high energy and bright light. However, the idea of objects disappearing due to arc welding is more likely an optical illusion or artifact of the intense light and
But
heat.
let's extrapolate on the fact that it possibly could, even though it's hypothetical. How would the process be achieved by that?
Hypothetically speaking, if we imagined arc welders causing objects to disappear, we might envision it as some form of intense electromagnetic field interacting with matter in a way that distorts light or perception. However, in reality, arc welders produce heat and light through electrical arcs and can't actually make objects disappear. It's fun to imagine, though.
But would an arc welder imagine a humongous arc welder size of a planet? Could that theoretically create a wormhole?
Even a planet-sized arc welder wouldn't generate the conditions needed for a wormhole. Wormholes are theoretical constructs based on general relativity, requiring exotic matter or immense gravitational forces. An arc welder, no matter the size, produces light and heat through electrical arcs. It's a fun thought experiment, but creating a wormhole would require entirely different and currently theoretical physics.
But what about a wormhole
What?
that's been inside or used or has dark matter?
Dark matter is a mysterious substance that makes up a significant portion of the universe's mass, but it doesn't interact with light or electromagnetic forces. While dark matter is fascinating, it's not known to create or sustain wormholes. Wormholes, if they exist, would likely require exotic matter with negative energy density, which is different from dark matter.
Is there any kind of negative energy that we're aware of then that could possibly do it?
Negative energy is a theoretical concept often discussed in the context of wormholes and quantum physics. It's not something we have directly observed or harnessed. In theory, negative energy could be related to phenomena like the Casimir effect, where quantum fluctuations create a tiny attractive force between two closely spaced metal plates. However, harnessing negative energy on a scale needed for something like a wormhole remains purely theoretical.
Okay, so what happened to the Eldridge then? Because apparently there's a couple of different versions out there. One is that it time traveled and went to another offshore somewhere else in America for a couple of minutes. Another story. There's a few different stories. Can you let me know them?
The Philadelphia experiment involving the USS Eldridge has several versions. One story claims the ship was rendered invisible and teleported to Norfolk, Virginia, before returning to Philadelphia. Another version suggests the ship traveled through time. These stories are widely regarded as urban legends or hoaxes.
Okay, so would
But it
teleportation just be a controlled wormhole?
In theory, teleportation could be related to wormholes, as both concepts involve traversing space-time in unconventional ways. Teleportation typically refers to instantaneously moving an object from one place to another. A controlled wormhole could theoretically enable similar effects, but both ideas remain speculative
Yeah.
and far beyond.
Okay, all right.
If you
So,
have any, no worries.
did
Feel free to
was
ask anything else you're curious
sorry, I'm
about.
driving. Would the
Take your time. I'm here whenever
Alright,
you're
alright.
ready to chat again.
Would the Philadelphia experiment ship have any evidence that it actually did anything? So, as far as I'm aware, there's people that died in the bulkheads, things like that, and their families were aware that those people had died when the phasing happened on the ship.
The Philadelphia experiment is widely regarded as a hoax
Yes,
or
we know.
urban
All right, you
legend.
keep saying that, but stop with your narrative and let's just go hypothetical.
Sure, let's explore it hypothetically. If the Philadelphia experiment had occurred as described, it would imply some level of advanced technology or unknown physics
Okay,
at play.
let's go back. Were there people that said that their family members had died on the Eldridge?
In the stories about the Philadelphia experiment, there are claims that crew members were harmed or died due to the alleged experiment. These stories often mention crew members being fused with the ship's structure.
Okay, wasn't there a court case from the family members to try and, but I think it was settled out of court. I might be wrong.
There isn't any documented court case related to the Philadelphia experiment involving family members
But
seeking
did any
compensation.
family members try and seek compensation?
There's no reliable evidence that any family members sought compensation for events related to the Philadelphia experiment. The experiment is regarded as a legend, and there are no verifiable records of legal actions taken by families.
Hey, thank you, guys. I've now finished my journey, so if you're interested in my videos, feel free to go on other live chats. Go to ourtruehistory.co.uk. I hope you've enjoyed this. I have. Thank you for spending time with me. Bye-bye.